Okay, let's take a little bit of time and dive a little deeper into some of our transformations. So, just looking at our little notes page here, you've got the vertical change when you're doing the whole function. So, if I'm just adding something to the whole equation, that's going to shift it vertically. So, if I did plus 5, it's going to move the y-intercept up 5. If I did minus 5, move the y-intercept down 5. Then you've got multiplying. So if I multiply the whole function by something, so if I did times 3, it would stretch it out so because I'm going further up, and it's also going to change my y-intercept. Then we have the ones inside with the x. So when I add when I add inside here, really it's going to do the same thing as when it's outside because all I'm doing is adding uh, a specific number to the y-intercept. It's just going to get multiplied by whatever the slope is. And then for the last one, uh, if I've got a number inside with the x that's multiplied, it's just going to change the slope to either make it smaller or flatter or make it steeper. So that's what we would call a compression would be making it flatter, and stretching it would be making it steeper. And like it says here, it'll intersect on the y-axis because we're just rotating it from there. And on the other one, it'll intersect on the x-axis somewhere because of the way we shift it. So let's look at a few examples. I've got the function here that is f of x is 2x plus 1. And so the first one, we're just going to shift it by adding 1. So when I add 1 to that, 2x plus 1, I add 1 more to that, it'd be 2x plus 2. So all that happens, like my note said, we shift it vertically and we're just going up 1 unit. And so what I end up with is a parallel line that is just shifted up however many it says in that deal right there in my new function. So there would be my g of x, just shifted up 1, so moves just ever so slightly. Then I have down here, g of x would be multiplying f of x times 2. So I'm going to do 2 times 2x plus 1, which gives me 4x plus 2. So I'm going to go up, just up 1 again, as it doubled it. And I will be going up 1, 2, 4, and over 1. And it gives me a 2, 3, 4 over 1. Okay, almost had that off a little bit. There we go. So let's see how this intersects. So this one ends up, we're staying close to the same, but it ended up shifting up 1 and steeper. And this one would have just gone up 1. So if you notice, now that this has gone up 1, they're going to cross, but they don't cross till they're down here on the x-axis. For the next one, I've got f of x minus 4, so I'll take 2x minus 1 and say 2 times x minus 4 plus 1, which gives me 2x minus 8 plus 1. It's really 2x minus 7. So really I should go down 1, 2, 3, 4, 5, 6. 7 is going to be right there. And we're going to end up, because my slope did not change, we still end up with the parallel line. So all that changed was my y-intercept. So we'd say that one was shifted down 8 units. And my last one, I've got g of x is f of x times 3. So I would take, or f of 3x, sorry. So it would be 2, 3x plus 1, which gives me 6x plus 1. So my y-intercept stays the same. I'm just going up 6 over 1, so it'd be somewhere around there. Giving me a couple points. And because my slope increased significantly there, it gets a lot steeper. But getting steeper is all that really does happen there. So when we're looking at these changes, notice that multiplying the whole function by something is really the only thing that changes it in multiple ways. Um, doing it, adding something to the whole function just shifts it up or down, as does adding something to the x. Then multiplying by just the x is only going to change my slope. So you'll see some combinations of these where it might be g of x equals f of 3x plus 1. Then that gives you um, multiple different changes, but you're kind of able to see that it's one change, one change, one change, two changes here if you're doing that. So hopefully that helps as we are looking over your different functions and working with those.